Okay, just to supplement our discussion or lesson on exponential growth, let's take a look at some actual numbers seen with the COVID-19 pandemic. At the beginning, it was not called a pandemic, okay? And if you remember, in beginning of March, actually beginning like February, you started to hear about this new virus, which at that point, most people, especially in the United States, really didn't bother with how serious this could be. And they were completely, we were all completely unaware of the what was to come for the next few years, right? Back in March of 2020, what were you doing, right? We were just sort of, carrying on our daily activities as if nothing was going to change. On March 1st, there were 30 known cases of COVID-19. Back then, this virus didn't even have a name. It was just called the new coronavirus. 30 cases. And within 2 weeks, the number increased to 3,487. Right? At that point, there was nothing that was stopping it. Everything was working normal. And so the growth was considered to be exponential because, again, absent any inhibiting force, okay, any force that would slow down the process, bacteria and viruses grow exponentially. Right? So what do we have? P of t is the number of new cases at time t, okay? And we are assuming when t is equal to 0 and t is counted in days, was considered March 1st. So we start this clock at March 1st, 2020. And so what's t? This is 0 here. And in the first 2 weeks, the first half of March, we saw the growth from 30 to 3,487. So this is t is equal to 14. Remember, 14 days have passed, or 14 days passed. In 2 weeks, passed from March 1st to March 15th. And I believe this was a Sunday, because I remember sitting on March 14th at a pizza place when I heard that the society was about to shut down, and this was the last place I was going out to eat. And so, all right, so so what do we have here? When t is equal to 0, p of 0 is 30, okay, and then p of 14, this is the date was March 15th. We have 3,480, okay, and then this is when the shutdown took place. Pretty much nationwide, some states earlier than others, but pretty much in most states, there was an order to stay at home, right? Because unless it's absolutely necessary to go out, like to buy groceries, you should just stay home to stop the process, to stop the growth and the spread of this new scary virus called the coronavirus, okay, later known as COVID-19. So how do you describe this, growth, right? Remember, this is always the initial value times e to the kt, right? We have to know what the k is. Well, we are given that p of 14, which is 3,487, is 30 times e to the k, and then time is t 14. Okay, so e 14k is equal to 3,487 divided by 30. Okay, so that means k, or 14k, is the log of that number, the fraction, right? And then k is then 1 times, or 1 over 14, that log number, log of 3,487 divided by 30, and that value divided by 14, right? That's what k is. Now you can calculate this easily on your calculator, and that turns out to be 0.3396857 approximately. Okay, so we have an equation that describes the number or predicted number of cases at time t, where t is counted in days since March 1st, 2020. And that equation is 30 times e to the 0.3396857 t approximately. Okay, now you can go ahead and use this number and put that in the memory to enter in your calculator instead of using this decimal approximation. That's okay too. All right, and so if you do p of 14, Of course, that you will get exactly 3,487, of course. Okay, now why is that? Well, that's because we used that number, we use this number to figure out what K is, right? So of course you get that. But using this, if you just plug in 30, okay, so this will be 30 times e to the 0.3396, whatever that number is, times 30, right? So if you plug in number 30 here, you will actually get 799,520, approximately 800,000 patients, okay? And if you evaluate this at t is equal to 45, you can plug in this number here and you will see that this is approximately 140 million. Okay, so what's going on? So this is what's happening, okay? And I hope you can see the power of what happened when the country shut down, okay? If the country had not shut down, and if people behaved as they always had done, without any inhibiting factor, okay, if the viruses were allowed to spread in at the same rate as the first half of March, remember it only went in 2 weeks, it went from 30 to 3,000. And you say, well, this is still a very small number compared to the hundreds of millions of people who live in the United States, right? Right, but if nothing had been done, okay, and if the exponential growth continued, okay, without any masks, without any shutdown orders, then we would have expected that by the end of March, we would have expected 800,000 cases. But instead of 800,000 cases, we only got 186,000 cases. This is a bad number. This is a huge number. But compared to what it could have been, 800,000 plus, okay, this is actually not terrible. And in fact, if nothing had been done until the middle of April, guess what? By April 14th, this is only, what is that? This is 45, right? This is 30, okay? This is 45. After 45 days since March 1st, which would be the middle of April, we would have had 140 million US cases. But instead of 140 million, we had 630,000. Again, this is a large number, but nothing compared to what could have been, which is 140 million cases. All right, so something happened when this shutdown was given as an order. Even though maybe some people did not wear a mask or some people did not completely shut down, it turned out it actually had some significant effect, because this number could have been 140 million, but instead it was even less than a million. In fact, it was just a little more than 500,000. And so that is an illustration of how scary exponential growth can be. All right, now I said P of t is 30 times e to this number, right? Approximately like this, okay? Now you can take this number, and in fact, this number here is 1/14 times the natural log of this, right? You could actually calculate that number. That's 1.4045 approximately times t. And what this is saying is that in the first half of March, when t went from 0 to 14, okay, the rate was 1.4. Okay, what are we talking about? It says 40.45% increase was observed every single day. Okay, so every day the number of known cases was growing by 40%, which means that you multiply that current number by 1.4 to get the number for the following day. Okay, and for the following day you add 40%, and for the following day you add 40%. This is an incredibly fast rate, a very high rate of growth, and that's what alerted the health officials and saying, look, even though right now you're seeing 3,000 people, at this rate, according to this calculation, by mid-April, you're going to have more than 1/3 of the population of the United States getting this new virus. Let's do something drastic. And that's why they took such a drastic action. All right. So this is, again, what you can see from the differential equation, which came from calculus, to predict the numbers like this. All right. So with this application, we will finish section 6.8 on exponential growth. Thank you.